All right, we are back. It's actually just 30 seconds since the last video from me. It's hopefully 2 days for you guys. We are on to lenses, which is topic 4. This is still using refraction, but this will all make sense. Again, I'm going to put a really good online thing you can do, a PHET simulation for this, which will be fantastic. And if you play with it and see how things work, you can really kind of have a good time with this. I'll probably do a short video of me playing with it as well, so you guys can see what kind of things you might do. So here we are. So there are 2 types of lenses, just like there are 2 types of mirrors. There's concave, which means they're bent in and the light is traveling this way, and so it hits the inner portion of that lens. And then there are concave lenses, which means the light is traveling this way and hits the bent out surface. So those normal lines change depending upon where you hit those parts of those lenses. And so a concave lens has a tendency to flare light and send it out away from, it's divergent is the proper scientific word. And a convex lens is convergent. And you guys practically don't have a ton of experience with one of these, but one of these double convex lenses, you guys have all probably at some point in time in school played with a magnifying glass. And that's what this is. Okay, and that's why you're able to, not condoning it, but you're able to fry an ant with a magnifying glass because light is traveling through and it converges this much light into a pinpoint spot and it makes it really hot and you can kill an ant and those kinds of things are, there was that movie where there was a kid who had really thick glasses and he was able to start a fire on some deserted island. I don't know how realistic that is, but that was these kind of lenses that allowed him to do that. With lenses, we have these convex lenses. A single convex lens doesn't do quite as much because it doesn't have normal lines on this side. It's just flat, and so it doesn't do quite as much, whereas a double convex lens does more more converging of light. Similarly, a double concave lens does less diverging of light than a single convex or concave lens does. So one of the common things that we will see in the images we take that we use is an inverted image. That's because the image has gone past the focal point and is inverted itself. If you were to look at the same image just inside of this focal point, you would be able to see that rose still upright, just larger. And so that's how that works. Your eyes use lenses all the time. We'll be putting a video up shortly about myself and Mr. Dirksen doing an eyeball dissection. We're going to film that right away here. But what happens with this is your eye is the lens in your eye is there to focus all the light that's coming into your eye onto your retina. And so that retina is the color sensitive and light sensitive portion in the back of your eye. And your lens does that perfectly. If it doesn't do that perfectly, you probably wear glasses. And so we'll put, if the light is going past your eye, which means it's going too far, you're called farsighted. And so we'll put a converging lens in there like this, a double concave lens, and that converging lens will bring the light a little bit narrower into your eye so that it's focused onto your retina properly. And if you are nearsighted, and I'll put a really good video on farsighted versus nearsighted onto the Google Classroom as well. If you are nearsighted, it means that the image is formed too near to the lens and the image is blurry. And so again, we'll put a diverging lens on or a double concave lens to spread the light out a little bit further so that when it reaches your retina, it's again focused and clear for you. One of the things that can affect this actually is the shape of your eye. So for some of you guys, if you are farsighted, your eye may just be a little bit too short. And for some of you guys that are farsighted, you may have an oblong eye, an eye that's longer than normal. As compared to someone like myself, I have like pretty close to 20/20 vision. And so I'm able to get the image perfectly focused onto my retina. Actually, this eye is a little bit, this is my left eye. My left eye is a little bit weaker than my right eye, so I might be getting glasses sometime soon to go and correct it. I don't know if I'm nearsighted or farsighted yet. I'm gonna hit a pause here for 1 second. All right, I'm back. So this is a camera, this belonged to my dad. This camera is actually older than me, but it is actually something, we make lots of things as a species that is kind of mirroring stuff that happens in nature. And so this particular camera has a lot of features that are very similar to our eye. So this camera has a focal adjuster here, so I can adjust my focus a little bit. Our eye has ocular muscles or ciliary muscles on the either side of our lens, and our lens can actually be reshaped to go and bring things into focus. This camera has a thing in it called a diaphragm, and what that diaphragm does is it actually changes the amount of light that can come in or out of the camera. For us, we have a diaphragm almost, but we would call it a iris. And so our iris, if you're really bright in something really bright, your iris will close up and you'll only have a little tiny little black dot in the middle of your eye. But if it's nighttime and you're trying to let as much light as possible in, you will probably have a really big black dot in the middle of your eye. And that black dot is called your pupil. I know that. But your pupil size will change depending on how much light your eye needs to get in. Do you want to try something really fun? You can hit pause on the video here in 1 second, but just try this at home. So take one hand and cover one eye like this and leave your eye open underneath it, and just keep your other eye open. This eye is going to stay open for a long time. Pause this video for like 30 seconds, and then when you're done after about 30 seconds, hit unpause. Ready, set, go. All right, so we're back. Now that our eye is covered like this still, what we're going to do is we're going to take our other hand off of our eye, and we're going to go and we're going to blink back and forth really quickly, closing one eye, then the other, then the other, then the other, okay? So we let this come out, and you go like this, back and forth, and even the short time that I was sitting there with my eye closed, now I can tell a difference between the amount of light that each side is letting in. This side is most definitely letting in more light because my pupil has dilated, allowing more light in. And this side over here was letting in less light because it was accustomed to the brightness of my classroom. And so you can try that again. If it didn't work, it should, unless you have... If it didn't work, you should go see an eye doctor. Okay, so those parts are very similar. In the back of your eye, there's a photosensitive layer called a retina. It has two different kinds of cells in it. It has rod cells and cone cells. Rod cells are there to pick up light intensity. Cone cells are there to pick up color. And so we'll talk about color sight a little bit later on. But that's the same thing as the film inside of one of these cameras, or if it's a digital camera, you just have a sensor in the back of it that picks up the amount of light and the color that comes into it. So those are the ways that our eyes are very, very similar to a camera. And again, I'll put a video up for you guys that does a really good job of showing this again if I wasn't doing a good enough job for you. I'm gonna scroll because I don't really care that much about this. This is not essential stuff. Oh, look at this old guy. He probably needs some glasses. I know a couple of people, maybe your parents are one of them, I don't know, that have reading glasses, which are glasses for seeing near, but then they may have something called bifocals, which basically have two different prescriptions in them, one on the bottom for reading stuff, one on the top for being able to see things far away. So those things there, if we put them in our glasses, are called accommodations. They're just things that we use to just adjust how our eyes pick up stuff. Oh, really cool thing. Little babies when they first come out, the distance that their eye is able to focus is about this distance from when they're held in their mother's arm to their mother's face, so that they can imprint on their mother's face and realize that this is the person that brings life and keeps me alive and keeps me safe. And it's something that we as a species do so that, well, not just we as a species, as life, lots of the higher life forms have that imprinting nature where they will be able to focus on something that's important to them early on in life. So This picture always reminds me of that. I have already talked about these two images here. Changing the size of the aperture is the same thing as changing the size of your pupil. Some people, if they have to go in and get a laser eye surgery or something like that, they may have their pupil dilated. They put dots in and it makes the iris retract as much as they can, leaving a larger pupil. Iris reflex. This is if you're ever okay. I'm maybe a bit mean. I've done this to my kids where I've walked in and taken my phone's flashlight and like turned it on right over top of their face when I wake them up, just to see, just to be a terrible human being is what it is. But you have iris reflex and you go from that really flared out pupil to a really small pupil pretty darn quick, actually. And so it just takes a little bit of time to acclimatize. You guys have all experienced this when you walked out of a movie theater or when you walked outside after a time in a darker place and it's really bright, especially like right now, it's crazy bright outside. So that is a possibility. I would highly recommend you go and look this up. This is blind spot test. This is a ton of fun. I'll put a video link on there too for you guys so you can test out your blind spot. That'll take a little bit of moving back and forth. This part here, we'll talk about this. You should draw this image on paper for yourself. We're going to dissect an eye for you guys and you will be able to see the vitreous humor. It's super cool. You won't be able to see the aqueous humor in the front of the eye. We'll show you guys the pupil and the iris and we'll get it all over our hands and you will marvel at the color in the back of the eye, all sorts of really cool things that you will see. And I'm gonna put up so many videos this week. I'm gonna put up so many videos about different animal eyes. I just have a crazy amount of videos because this unit actually I really enjoy a lot. If you've ever gone to an eye doctor, you've seen this done. Which one's better? 1 or 2? A or B? Which one's better? And it's really irritating, but they are basically just putting different lenses in front of your eye and seeing which one is clearer for you so that when they do give you a prescription, they can get the exact right prescription for you and you'll be able to see as well as I do. Again, I would normally give these questions at the end of this topic and make you guys do them. We are busting through this pretty quick. If any of these questions, again, are problematic for you and you need some help, feel free to email me or Mr. Dirksen and we will most definitely help you guys out. Other than that, we will see you guys next class. I probably won't load up. I have so many YouTube videos I'm going to blast at you guys. Watch them all. Just keep track and write some notes out of them and then we'll see you guys next week.